Hi there, Jim here. Today I'm going to show how to use an electronic load testing device that I'm going to unwrap here in a second to determine the capacity of a 12 volt lead acid battery. So we're going to kind of go through the whole process, but I thought just before we get into the how to use the load tester, I would do the unboxing as well, in case some of you are wondering about what comes in the package when you order one of these. So I ordered, we'll just open this up. You can see the unit here. There's a battery box here. So this is designed to hold a variety of different rechargeable batteries, generally lithium-ion batteries. And you can see the sizes are indicated on the back. So 26 650, 18 650, 14 505, okay, double A, 14 340, 14 250, right? So these are a variety of different sort of common sizes for rechargeable batteries, or in some cases not rechargeable batteries. And so this is a battery box, obviously labeled, and it's designed to plug in with these contacts, or maybe in some cases with these contacts, into this item, which I got from a company in China called ATORCH. So they make a variety of these. And so let's just, this plastic kind of comes out like this. And there's some stuff in the box here. Okay, so there's an adapter. If you happen to live in Europe, there's I think, well, there's a sticker for the manual, but there's also inside here a power supply. Okay, and so this is designed to give us 12 volts at up to 1 amp. Okay, then we've got another thing to plug in to test or to put a load on a few different things, and I guess that would allow us to test power supply modules. So we have Type C, micro USB, mini USB, and DC. Okay, so you can see those there. Zoom in. And scrunched in here a little bit before we come to this main unit. There's a set of test leads here in the package for a variety of scenarios, some heavy gauge ones, because this can carry a fair amount of load, and sort of a quick start guide here. Okay, empty box. So we've got this, and let's pull that out. Okay. All right, so we've got this unit, and this unit is designed to be able to put a load onto a battery or some other kind of device. We're going to use a battery. It's got a very large heatsink here with a fan for cooling. Okay, this is where the power plug goes in, so we'll kind of set this up. And really the focus for this video is going to be, how do I use this device to do a capacity test to learn or determine the capacity of a battery, because really the only the only true way to assess the capacity of a lot of rechargeable batteries is to put it under load and drain it and measure how much power came out of the battery until it reached a drainage point. And usually batteries are considered drained when their voltage drops below a certain critical level. And of course, that'll vary depending upon the type of battery and the test protocol. So we're going to be going through in this video the test protocol for a 12 volt lead acid battery, and in particular the battery that I'm going to be testing is this one. Okay, so you can see, make it look light. This is a battery. The main brand here is Energy King, but if you can see the logo in the corner, Cheshing Champion, that's the OEM manufacturer in China that made this battery. The one really annoying thing about the battery is you can see there's not a lot of labeling here on the battery if you want to kind of assess how to make use of it. I have another Energy King battery here. So this is a kind of very similar. It's in the same series. Okay, so this is an NP712. So this is a 7 amp hour battery. The 7 is the amp hours and the 12 is the voltage. And this one is an NP912, 9 amp hour. You can see that this one has quite a bit more information in terms of, 7 amp hours over a 20-hour test. And so we'll get into what that means in a few minutes, what it means to do a 20-hour test. And this also has information about the cycle voltages, the standby currents to use, and the maximum initial current that you should limit your load to. Okay, so that appears on this one. It doesn't appear on this one. Why they chose to not put that information on the battery is a mystery to me. Since these are in the same series, at least when I look them up on their website, I'm going to use the sort of same information that I got. Well, there's some information here, and I found a data sheet for this one. I'm going to use some information from here to do in the assessment here. But the main thing we're going to be doing here is we're going to be doing a 20-hour load test on the battery using this electronic load. And in that load test, 20-hour load test means using, let's say 5%. Okay, so we want to use 5% of the capacity over a 20-hour period. So the capacity is 9 amp hours, right? Remember that? So we want to draw 20% of the capacity, 5% of the capacity over 20 hours, and we should be able to pull a total of 9 amp hours out before the voltage drops below what is considered the drained level. And I'll show that on the screen what the drain level is. I don't remember it off the top of my head right now. Usually it's around, it can vary depending on the test protocol, but it's usually about 1.6 volts per cell, and there's, I think, 6 cells in there, something like that. And at that point, when it reaches that level, even though there's still a voltage there, the battery is technically considered to be drained. Okay. So, what are we going to do? Okay, so that's what we're going to use as the test protocol. We're going to be trying to run this at a 5% load, so 5% of 9 amp hours. So 10% of 9 amp hours would be 900 milliamps. So 5% is going to be 450 milliamps. So we're going to put a 450 milliamp load on this using this device, and then we're going to run it through, and before the volt, we should be able to get 9,000 milliamps or 9 amp hours or 9 amps out, 9 amp hours worth of power out of this battery. Sorry for the marbles in my mouth over the terminology. Okay, so without further ado, we'll just stand this up, put it there, rearrange things. And so the next thing I want to do before we kind of get into the battery is we're going to plug in this unit and have a look at what this does. So there's a variety of controls down here. And so the next part of this video is going to be a little bit of a how-to. How do you make use of this unit? So what's the process? What are the controls used for, and all of that? So how does this electronic load work? This unit does quite a lot of things, and it's going to take me more than one of these videos to go through all of the features and functions in the unit. Aside from testing batteries, it can also give power supplies a run for their money. So you can see that this, once again, this board, which attaches over here, it can take a barrel connector, it can take the older mini USB, micro USB, and USB-C, and it can put a load on the power supply with these different output types, and it can put up to, this unit can put up to 150 watt load, which is typically more than most laptops will draw. And there's another model which I may show later on, which has a sort of slightly higher capacity and can take a load up to 180 watts. And so, you know, and then this will also interface via Bluetooth, and it'll also connect to your PC. So it'll do quite a lot of things, and it's got a lot of controls, and there are only 4 buttons here to control the operation of the whole thing. So it is going to take me a bit to go through what all of the different controls do. Now, when I start working on the controls, I'm going to be zoomed in quite tight, so you can see what I'm doing, both with the buttons here, and you can see what's happening on the screen in response. Right now, I think that's too small to really see what's going on. Before I start that, I just want to mention something about the wiring. So the unit comes with, well, 2 of these, a red connector and a black connector, and you can see that they have a spade at the end. And if you make use of these, you can certainly make use of these for testing voltage. You know, the spade kind of slides in there, and it doesn't go in one slot. It actually goes into both slots, and you know, the red and the black. And because it has 4 contact points here, one contact point is for doing the voltage sensing, and the other one is for doing the current draw. And so, so this is what if you do this like this with these, you know, 2 contacts, or 2 leads, that's what the manufacturer calls the 2-wire method. And there's also what they call a 4-wire method, and that's the way I have it wired up now. And it claims that the 4-wire method is, they use the term more professional, but I'm going to assert that the 4-wire method is probably a little more accurate. And the main difference here is that instead of splitting the voltage here, you know, and running the same thing, and just splitting the voltage right here at the contacts, the voltage instead and the current are split in the clamp here. And so these leads don't come with the unit. I had to build these leads myself. So, you know, I've used some 12 gauge silicone wire here. Not sure if it'll focus on there. Okay, so 12 gauge silicone wire, and I've run both, you know, this is per the manufacturer's instructions. Both of these leads run to the clamp, which is going to be the test point on the battery. And you can see I've kind of soldered both wires into that test point. So this just moves the connection, the split. So the split between voltage and current is moved up to this contact point, as opposed to being relegated all the way down to only being split over here. And in theory, this is more accurate. The other thing that's a little better is, of course, I made these leads a little bit longer, and so it's a little bit easier to work with these, especially when dealing with larger batteries. So essentially, we take these leads, hook up to the positive and the negative. Now it's not on right now, and this battery is fully charged. And so now that these leads are hooked up, and you can see that we can see that currently we're registering a voltage of 13.07 volts. So that's I think that's a pretty fully charged battery. I had this trickle charging for a couple of days, and it's also had some time to settle. And so there are some stale settings here as well, and I've kind of left them on the unit on purpose. And now what I'm going to do is I'm going to zoom in so that we can see what's going on specifically in the display and with the controls. So you won't see the whole test setup. You probably won't see the fan here. You may hear it when it comes on, but otherwise we're going to be focused into this really small tight space here. All right. We're zoomed in quite close to the control screen. And so we can see that there are only 4 buttons here. They're labeled in English and Chinese. This one is setup. This one is minus. This one is plus. And this one is start. And also, you might be able to make out at the bottom here, it says on off. Then in terms of the display, there are a couple of things that we can configure. I'm going to skip the top line for a second because it changes. But we can see that there are a few readouts. And on the one hand, it's nice that the manufacturer has kind of used all these funky colors to separate between the readings. But in some cases, these colors are pretty difficult to read. Of course, we can make it a little brighter by pressing a button here. Because there are 2 brightness settings on the LCD. So we have a voltage reading, so that's the current voltage on the battery, and you'll see that that voltage is shown both when we're not running and when we are running. We also have a current readout here in amps, the power readout here, the resistance on the battery circuit, and then a couple of things. So this power is watts, instantaneous watts. Then we have the energy, which is a cumulative amount. So, over the course of a test, this energy readout will increase to show how many total watt hours have been gathered over the course of the test, and also a capacity in terms of milliamp hours here, and that will change over the course of a test. And then you can see at the bottom here, maybe there's a timing, and so that will tell us how long the test has been running. So this is showing some results from the past test, and we'll see how we clear these out in a second. So we have the timing of the test, and then we have the temperature from a temperature probe. So there is an external temperature probe that can be hooked up. I don't have it hooked up at the moment, but if you want, you can take that temperature probe and you can tape it on or pin it onto the battery or other device that you're testing, and you can set certain control limits for the test, and that will display here. Okay, now once again, skipping the top row for a second, we can have a timed discharge test. In other words, the test will run for a certain amount of time. I'm not using the time discharge mode just yet. So there's no time set there. When we're running a sort of a voltage-based test, if you will, the way we could tell, typically the way we tell whether these cells whether the battery is charged or whether it's, let's say, discharged, is when the voltage falls below a threshold. And for for sealed lead acid batteries of this nature, or for lead acid batteries in general, a common cutoff voltage per cell is 1.75 volts. And these batteries have 6 cells, and so 1.75 times 6 is 10.5. And so when the voltage drops below 10.5 volts for the group of batteries, that's when the system will say, okay, the test is done. Then you can see here we have an internal an internal temperature monitor. So the circuitry that's hidden underneath the fan has another temperature sensor there, and that temperature sensor is currently showing a temperature of about 20 degrees Celsius. And then we can see the battery internal resistance here. That'll be visible when a test is running. And then the run state, currently it's off. You can see if we turn it on for a second. Whoops, wrong button. If we turn it on, it'll change to on. Okay, but and we'll see the resistance here. But I haven't said anything for the test, so that nothing is really happening other than the state change. Okay, so now that we've gone through what all the readouts are, let's kind of go back to the top line, which is where the controls are. And so we see here that right now we see CC. So this can operate in four major modes. There is constant current mode. Let's see how we change that. Yeah, so if we hold the setup button down, that starts that flashing. So we have constant current mode. Okay. Constant current mode, and then I can press this. No, not that. I can go to constant resistance mode, so it'll put a specific resistance on the battery for the current to flow through. Whoops, it's timing out on me. There's constant resistance mode. There's constant power mode, so we can set a specified power that we want to run at. And there's constant voltage, so we can say that we want the battery to run at a specific voltage. And so we'll go through and I'll show how most of these, I'll show how all of these modes work. And so in order to generate, of course, a constant voltage, the current is going to end up varying in order to keep that voltage drop. So once again, if we hold the setup down, and we can press plus or minus here, but it goes through those 4 different things: constant current, resistance, power, and voltage. And of course, as long as we keep the button, as long as we keep pressing the button without waiting for it to time out, it'll stop. Okay, so I'm going to stop on constant current because that's the most commonly used mode that I want to use when I'm testing, because typically most battery capacity tests are based on a constant current load, and then that constant current load is run for a specified, it's run until the voltage drops below the threshold. Now, of course, you see here for each of those modes, you may have seen as the mode was changing, this was changing. And so in constant current mode, I'm going to put an amperage load on it. In constant voltage mode, I'm going to say what voltage I want it to be. In constant power mode, I'm going to input a power level. And in constant resistance mode, I'm going to enter a resistance here. And so this top line shows both the mode here, but it also shows what the loading factor is that I'm applying. And so if I use the plus and minus keys. So in this sort of bare mode, minus doesn't go below 0, but plus I use that. It changes the digits. Now I can, instead of a long press, a short press on the setup key button moves this sort of little underscore. I hope you can see that. It's there now, it's there now, it's there now, and there's there now. And so that just cycles around. And then what I can do is, so for example, what I'm going to want to do here is I'm going to put a 2 amp load. Actually, let's put a 1.5 amp load on the battery. So we're going to put a 1.5 amp load on the battery. So I'm going to move it around. I can go up and down here. Okay, so now you can see that it said the current setting is 1.5 amps. We're in constant current mode. And if I start this now, it's going to put that 1.5 amp load on. But before I do that, what I want to do is I want to go through and I want to clear the settings from the previous run. So there is now there's a whole settings panel. So if we take the start button and we, instead of a quick short press to start the run, we give it a long press, you can see that it goes into the menu here. And there are a lot of settings here. Now, one of the things to be careful about is, plus and minus are used to change the settings. And the first one is the language. Fortunately, there's only 2 languages. And so if I were to mess it up and put it into Chinese, I'd probably be able to easily correct it. Okay, so English is what I want to have. And to move through the rows here, I use a short press on the setup button. I can never figure out which one I want. Okay, so short press on the setup button moves through the rows. What I want to do here, we go to clear cumulative data, and to clear the data, to invoke a particular line, we do a short press on the what's labeled as the start button. So if we do a quick press here, you can see it says OK. And then if we advance through these lines, and quick press here, we come back, we now see that the capacity here has been zeroed out and the timing has been zeroed out. And I'm hooked up to the battery, so the voltage is reading 13 volts. If I disconnect the battery for a second, you can see that it's reading 0 volts. So we'll hook that up again. And now what we want to do is we want to initiate starting a test. And so we've set it up in constant current mode at 1.5 amps. And I press the start button. And you can see it sort of takes a second or two to get into its groove. It shows that it's on. It shows the battery resistance here in milliohms, and it now also it's showing me an internal temperature, so it's warming up a little bit, 22 degrees. The fan is running. You might be able to hear that, and a bunch of other stuff is happening here as well. So the voltage continues to kind of dance around a little bit as the circuit runs and as the load is placed on the battery. Because what this system is trying to do is it's trying to maintain this current at 1.5. And of course, as the current is being drawn from the battery, the voltage is going to change a little bit. And so there's a little bit of, how would you put it, sort of jumping around, if you will, jitter in the values. But not very much. Of course, over time, because we're drawing power out of the battery, the voltage is going to drop over time until we reach the cutoff voltage. Now, The other thing we can see here is we can see how much power is coming out. And so that's currently showing about 18.7 watts. Once again, values sort of jitter around. That's the voltage times the current. So 12 times 1.5 is about 18, and some decimal points there. Res, so this is the resistance, and so that's the value of resistance that's being generated in the internal circuitry in order to put that 1.5 amp load on on the battery. Okay, so this the circuitry is simulating an 8.3 ohm resistor at this point. Then we can see that for the amount of time the test has run, so far not very long, we've generated 0.7 watt hours, 58 milliamp hours of current have come out, and the test so far has been running for about 2 minutes and 30 seconds. That's the amount of time that I've been talking through what all these different settings are and what they mean. Okay, maybe it'll run a little bit longer at 12.7 volts. And there we go, 12.7 volts. You can see this is the typical test configuration. It's dropped below the cutoff voltage, 1 watt hour, 3 milliamp hours. It ran for a total of 8 seconds. Now, normally the cutoff voltage isn't going to be set anywhere near so high because the initial voltage drop when you put a load on the battery is quite high. So typically we would be doing something more, so for example, even if we reduce the cutoff voltage to 12 volts, it'll take quite a long time to get there. Okay, so this is kind of more of a typical test, but there are a few sort of tenths of a volt that drop right off the bat, and so but the display you saw is what we would see just with a different cutoff voltage in a full test. And in a full test, I would typically have the cutoff voltage set as I showed at 10.5 volts would be a more typical cutoff voltage. Okay, so that's all the basic functionality. So those are the features that that I generally would be using if I were going through a typical capacity test on a 12 volt battery like this. And so, or for that matter, any capacity test of a battery, including a lithium-ion battery, or any battery for that matter, any battery that that we could test. In the next videos, we're going to have a look at the other modes of operation that are available here, like the constant resistance, constant power, constant voltage, and we will we'll see how some of those other functions operate, and we'll also have a look at how we can use the unit to test things other than batteries. So we'll have a look at how we can use this unit to test computer power supplies to ensure that they're able to handle the load that they're supposed to be able to handle. Okay, well, thanks for watching, and please do subscribe to my channel.